Hi everyone, in this video we are going to practice drawing the three-dimensional shapes of a bunch of different Lewis structures. So the goal of this video is to be able to take these Lewis structures and then be able to draw them out in their actual three-dimensional geometry, and then hopefully after you've been able to master that you can then follow up with the second video where we're going to practice the bond angles of these exact same molecules. So really please note that this video should be watched in tandem with the following video on bond angles, okay? Alright, so the first thing we're going to do is go through these four structures that I consider to be one of those that you should just have in your back pocket. So in theory, for the rest of the semester, when I say methane or ammonia or water or carbon dioxide, you immediately know what their shape is. So take a second and make sure that's correct, that you actually do know what the shape is of all of these. So you should draw it out and then tell me what the name is of the three-dimensional shape. Go. Alright, did you get an answer? Hopefully this was super easy for you because you know these like that, but just in case it's not, let's bring us all to the same page. So the first thing you have to do is draw out the Lewis structure of each of these, and so hopefully by now this is super easy for us. We can easily draw out these structures, and I'm going to do them in the three-dimensional structure too, just so you can kind of start getting comfortable with that. But basically when you draw out methane, it should look like this. You have carbon in the center and it's surrounded symmetrically by those four hydrogens. So now this has four different regions of electron density around the central atom, which is carbon. There are 0 lone pairs on it, and so by definition this is considered a tetrahedral geometry. Okay, so tetrahedral. Let's move on to ammonia. If ammonia is drawn properly, you have a nitrogen that has a lone pair directly on that nitrogen, then you have a hydrogen, another hydrogen, and then another hydrogen. So there's a nitrogen on top and the 3 hydrogens point down. So this is 1, 2, 3, 4 regions of electron density, 3 of which is an atom, 1 of which is a lone pair. So this is considered trigonal pyramidal. Okay, trigonal pyramidal. All right, next one, water. Water we've seen drawn a million different times. Okay, there's an oxygen in the center, hydrogens on each side, and then oxygen has 2 lone pairs of electrons on it. So we have 1, 2, 3, 4 regions of electron density. 2 of them are atoms, 2 of them are lone pairs. By definition, this is a geometry that is considered bent. Okay, that's what we call bent. All right, so now we have one more of these that I expect you to just know. Carbon dioxide, we put carbon in the center. It is doubly bonded to oxygens on each side. It is a very symmetrical molecule. So this carbon right here is our central atom. There's 1, 2 regions of electron density around it. Remember, a double bond counts as 1 region, all right? Nothing fancy. So there's 1, 2 regions of density. These are both atoms. There's no lone pairs. The only way you could draw this out properly is by saying that this would be a linear molecule, okay? Hopefully those were easy. These are 4 you just need to know. So if you don't have those memorized, make flashcards for them pronto and do that right now, okay? All right, for the rest of you, let's move on. We have 3 examples here. Same thing. Draw out their structure. I want to know what is the name of their three-dimensional shape. Go. All right, so these were a little bit harder, so if it took you just an extra second or two, don't worry about it. The biggest thing is that you're practicing, and I'm really pleased and proud of you for that, actually, to be completely honest. All right, so now let's start from the top. PBr3, if you draw this out properly, you have phosphorus in the center, and it's surrounded by 3 different bromines, okay? So it should look something like this. Each of the bromines has 3 lone pairs of electrons on it, and then the phosphorus has a single lone pair of electrons on it as well. So if we look at our central atom, this phosphorus, we can see it's surrounded by 1, 2, 3, 4 regions of electron density, 1 of which is a lone pair. This geometry would be called trigonal pyramidal. It is the exact same structure as NH3 is that we did in our previous example. So hopefully as you're going through this, you're going to start to see patterns. If you see something like this, that's a group 5 atom and it's surrounded by 3 different things, it's probably going to look like a trigonal pyramidal, or the way ammonia does. So just start to try to recognize these patterns, because hopefully that's going to make things easier for you, okay? So same thing here, silicon, and then it has 4 different fluorines around it. So I'm going to put silicon in the center. I'm going to put a fluorine here on the top with 3 lone pairs of electrons, and then we're going to surround this symmetrically around the silicon. This should look very familiar to you. We just drew something very similar to this. We drew methane before. Now this, the same structure, silicon in the center, 1, 2, 3, 4 regions of density around the outside of it, none of which are lone pairs. This is definitely a tetrahedral molecule. And again, this looks just like methane, right? So if you see something from group 4 and it's surrounded by 4 different things, you should be thinking, okay, that's probably going to look something like methane. Start to notice these patterns, guys, okay? All right, SH2. S is going to be in the center. Our hydrogens are going to be on the outside. So since sulfur is in group 6, immediately I'm thinking, ooh, that kind of looks like water, right? So we have 1, 2, 3, 4 regions of electron density, 2 of which are lone pairs. This is definitely a bent geometry. And again, it's the exact same structure as water. So start to notice these patterns, because then it's going to be so easy for you to just fling that thing out, determine the bond angles, bam, answer the question, and move right on. All right, so let's do one more together. These are a little bit trickier. They are ones that we've done in previous units, specifically ozone. We've done an entire unit on that, so make sure you know what that one is. But just go through this. Take your second, draw it out. Maybe it has more than one structure. Wink, wink, nod, nod. Go. All right, hopefully you were able to draw these out. We did a lot of these, especially the one with the ozone in the previous unit. So in theory, this should be something that you can draw out so quickly because you just are so sick of ozone because we spent so much time on it, but maybe, maybe not. It's okay if you've forgotten. All right, so this is what ozone looks like. Hopefully we recall that it does exhibit resonance, and so there's 2 different resonance structures. Regardless, they each have the same geometry. They have 1, 2, 3 regions of electron density around them, but one of which is a lone pair, so these would be considered bent molecules. Both of them are, okay? Then we have Bi3. So B is going to be in your center. It's going to be surrounded by iodine. There are 3 of them, so you can hopefully do this symmetrically around that boron. And then the iodines here, they each have 3 lone pairs on it. Our central atom is boron. There's 1, 2, 3 regions of electron density around them, none of which of these are a lone pair, so this is a new shape for us for this video. This is called trigonal planar. Okay, so it's flat. If you were to look at it, it would be flat on the structure. It would lay right nicely on top of a piece of paper or something like that. All right, SO2. SO2 is tricky for some reason. I don't really know why, but students always have trouble with this one. So let's just draw it out. Hopefully, based on, let me actually give you a little space, based on this earlier structure up here, you were able to just boom, draw it like that. Because it is the exact same structure as ozone. You have sulfur in the center, then you have an oxygen over here, and then you have another oxygen over here. It's literally the exact same structure as ozone. So if you had trouble with it, what I would start recommending is that you need to be doing more problems so that you can begin to recognize these patterns. Because hopefully you can look at that and be like, wow, I have 3 molecules from group 6 here. They're always going to be in this shape. They're the exact same shape as this one previously, so this must have a bent structure as well. Hopefully this is making sense. If it's not, that means you need to practice more, okay? Google molecular shapes and just practice all these things. There are going to be some examples that have crazy things like octahedral and trigonal bipyramidal and whatnot. We don't go into that in this class, so don't freak out if you see those examples. Just know that we only go up to tetrahedral, okay? Have a great week. Practice, practice, practice. Take care of yourself. Drink water.